Hello viewers, in today's session we are going to discuss an important and conceptual problem from definite integrals involving the modulus function. So here we have to evaluate this definite integral where the limits are from 0 to half and the integrand is a mod function, right? So here we have a mod of x times cosine pi x dx, and will solve this definite integral using three important concepts, including the method of substitution in integration, right? So let us first quickly see the three important concepts which are going to be quite useful in evaluating this integral. So let us first call this integral as I, right? And here we have the three important concepts which are going to be useful in the evaluation of this definite integral. So the first one is a definition of mod function. The second one is the sign convention for cos theta in four quadrants. And then the third one is integration by parts, right? So in the first case, we have the definition of mod function. See, the mod function is defined as mod of p is given by a positive p whenever this p is greater than 0, and mod of p is equal to 0 when p is equal to 0, and mod of p is equal to negative p when p is less than 0. So this is the definition of a mod function, right? And the second one is the sign convention for cosine function in four quadrants. Now see, when we have the four quadrants, here we have 0, here we have pi by 2, then we have pi, then we have 3 pi by 2, and here we have 2 pi. Now we know that from trigonometry that the cosine function is positive in the first quadrant and in the fourth quadrant, right? And in the second and third quadrant, the cosine function is negative, right? So from 0 to pi by 2, the cosine function is positive, and from 3 pi by 2 to 2 pi, the cosine function is positive, and from pi by 2 to pi, the cosine function is negative, and again from pi by 2 to 3 pi by 2, the cosine function is negative, right? And the third one is the integration by parts. Now see, we know that the integration by parts formula goes like this. If we have two functions, say u and v, and the integral u dv is given by uv minus, then we have v du, right? So this is the formula for integration by parts, where u and v are some functions of x, right? Okay, so now let us first apply the method of substitution. So here we have cos pi x. So let us first take t is equal to pi x, right? So that x is equal to t over pi, right? And here we can see that the value of x, it varies from 0 to half, right? Okay, now let us differentiate x with respect to t. So we have dx over dt is equal to d by dt of t over pi, and we can take 1 over pi outside this operator. So we have d by dt of t, and the derivative of t with respect to t is 1. So we have 1 over pi times 1, that is 1 over pi, right? So now we can write dx is equal to dt over pi. So now let us change the limits. See, here x varies from 0 to half. So when x is 0, then the value of t can be calculated from this substitution. T is equal to pi x. So we have pi times 0, that is simply 0. and when x is half, then t is given by pi times half, that is equal to pi over 2. So when x goes from 0 to half, then t changes from 0 to pi by 2. So let us now write this integral I in terms of t. So we have here t is equal to 0 to pi by 2, and then we have mod of x times cosine pi x. So x is t over pi, and then we have cos of t, and then dx is dt over pi. So now we can write this integral as 0 to pi over 2, and here we have mod of t over pi cos t, right? So we can take 1 over pi, that is mod of 1 over pi is simply 1 over pi, and then we have mod of t, and then we have mod of cos t, and here we have dt over pi, right? So here we have written this mod function as mod of 1 over pi, that is simply 1 over pi, and mod of t times mod of cosine t. Now 1 over pi and 1 over pi is 1 over pi square, and taking 1 over pi square outside the integral, then we have 0 to pi by 2, and here we have mod of t, and then we have mod of cos of t, and here we have dt. So now when t varies from 0 to pi by 2, right? Since t is a real number and all the numbers from 0 to pi by 2 are positive, right? So mod of t is equal to positive t whenever t is greater than 0. And here t belongs to the interval that is from 0 to pi by 2. Hence all the t's are positive, so mod of t can be easily replaced by positive t, right? And here we have a mod of cos of t, right? And mod of cos of t can be written with the help of this definition. So we can now write mod of cosine t as positive cos t whenever cos of t is greater than 0, right? And see here t belongs to the interval that is 0 to pi by 2. So we are in the first quadrant, right? That is from 0 to pi by 2. And when we are in the first quadrant, then the cosine function, that is cos of t, is positive, and positive implies that cos of t is greater than 0. So mod of cosine t can be written as that is positive cosine t when cos of t is greater than 0, and when t belongs to this interval, that is in the first quadrant, then the cosine function is positive, right? So we can now write 1 over pi square. Here we have 0 to pi by 2. Mod of t is positive t, and mod of cosine t is positive cos of t, and here we have dt. So now we have 1 over pi square, 0 to pi by 2, and we have t times cos of t and dt. Now here we can see that this is the product of two functions of t, right? So this function is a polynomial function, and this is a trigonometric function, right? So now we can write the integral I as 1 over pi square, and we have 0 to pi by 2, and here we have t cosine t dt. So we can now write t and then cos of t dt. Now see the derivative of sine t is equal to cosine t, right? So we can write the derivative, that is d sine t is equal to cos of t and dt. So we can replace cos of t dt by d sine t. So here we have d sine t, so that we can now apply the formula of integration by parts. So now we can take this function as u and this function as v, right? So using integral u dv is equal to uv minus integral v du, we can now write 1 over pi square, and then we have u times v. So u is t and v is sine t, right? So we have t sine t, and then we have the integral, that is v du. So v is sine t and du is dt, and the limits of integration are from 0 to pi by 2. So now we can write 1 over pi square, and then we have t sine t minus the integral of sine t is minus cos of t, and the limits of integration are from 0 to pi by 2. So we have 1 over pi square, and then we have t sine t plus cosine t, and limits are from 0 to pi by 2. So now let us substitute the limits and we'll take the difference. So we have 1 over pi square, and then first we have here t is equal to pi by 2, then we have sine pi by 2, then we have cos pi by 2. So first we have here t is equal to pi by 2, and then we substitute t is equal to 0. Then here we have 0 times sine 0, and then cos of 0, right? Okay, now let us simplify it. So 1 over pi square, and here we have sine pi by 2 is 1. So we have pi by 2 times 1, and cos pi by 2 is 0. And here this term is 0. Sine 0 is 0, and then we have cos 0 is 1. So now we have 1 over pi square, and here we have simply pi over 2, and here we have simply minus 1, right? Okay, so now multiplying these two terms by 1 over pi square, we have simply 1 over 2 pi, and here we have minus 1 over pi square, right? So viewers, the value of this integral is equal to 1 over 2 pi minus 1 over pi square. Hello viewers, in today's session we are going to discuss an important conceptual problem from integrals involving modulus function, and here we have to evaluate this integral that is from minus 1 to 0, and the integrand is the sum of three mod functions, that is mod of 1 minus x, then we have mod of x and mod of x minus 1, right? So now in order to evaluate this integral, we have to make use of the concept of definition of mod function, right? So here the definition of mod function is going to play an important role in evaluation of this integral, right? So let us first see the definition of mod function, and then we'll apply the definition to this integral, right? Although we can also solve this integral by taking the sum of three integrals, right? That is from minus 1 to 0 mod of 1 minus x, then from minus 1 to 0 mod of x, and then minus 1 to 0 mod of x minus 1, right? But here with the help of the definition of mod function, will simplify this entire expression in one go. So now a mod of p is defined as a positive p when p is greater than 0. So whenever p is greater than 0, that is p is positive, then mod of p is positive, right? And mod of p is 0 whenever p is equal to 0, and mod of p is negative p when p is less than 0, right? So let us apply this definition to these three functions. So here we have first mod of 1 minus x. So mod of 1 minus x is positive 1 minus x whenever 1 minus x is greater than 0, and mod of 1 minus x is 0 whenever 1 minus x is equal to 0, and this is negative of 1 minus x whenever 1 minus x is less than 0, right? So from here we can see that x is less than 1. From here x is equal to 1, and from here x is greater than 1, right? Okay, now a mod of x can be defined as positive x whenever x is greater than 0. Mod of x is 0 whenever x is equal to 0, and this is negative x whenever x is less than 0. And similarly we can write mod of x minus 1, that is positive x minus 1 whenever x minus 1 is greater than 0, and this is 0 whenever x minus 1 is equal to 0, and negative of x minus 1 whenever x minus 1 is less than 0. So from here we can see that x is greater than 1. From here x is equal to 1, and from here x is less than 1. So this is how with the help of this definition we can define mod of 1 minus x, mod of x, and mod of x minus 1. So now let us call this integral as I, right? Now see here the limits of integration vary from minus 1 to 0. So here we have minus 1, here we have 0, right? So the limits of integration vary from minus 1 to 0. So a mod of 1 minus x is equal to a positive 1 minus x when x is less than 1, right? So whenever x is less than 1, then mod of 1 minus x is positive 1 minus x, and here all the values of x which lies in the interval minus 1 to 0 are less than 0. So obviously all the x are less than 1, right? So here we can replace mod of 1 minus x by positive 1 minus x, right? Okay, now here we have a mod of x, and mod of x is equal to negative x when x is less than 0, and here all the x which lies in the interval minus 1 to 0 are less than 0, right? So here we can replace mod of x by a negative x. So here we have negative x, and then we have mod of x minus 1, right? Now see here again x lies in the interval minus 1 to 0, and here mod of x minus 1 is negative of x minus 1 for all x which are less than 1. And since the limits of integration here all the values of x lies between minus 1 and 0, so obviously all the x are less than 1. So here mod of x minus 1 can be replaced by a negative of x minus 1, right? So this is how we can simplify this integrand with the help of the definition of mod function, right? So in the first case, that is mod of 1 minus x, will make use of this part of the definition. Mod of 1 minus x is positive 1 minus x when x is less than 1. And in the second case, mod of x will make use of this part of the definition. Mod of x is equal to negative x when x is less than 0. So here x is less than 0. And in the third case, a mod of x minus 1, so we'll make use of this part of the definition, that is negative of x minus 1 when x is less than 1, right? So obviously all the x are less than 1 when x lies between minus 1 and 0. So let us now simplify this expression. So we have here 1 minus x, here we have negative x, and here we have minus x, and then we have plus 1, right? Okay, so now we can write minus 1 to 0, and here we have 1 plus 1 is 2, and here minus x, and minus x is minus 3x, and here we have dx. So now we can integrate this linear expression. So integral of 2 dx is simply 2x, and the integral 3x dx is simply 3x square over 2. And the limits of integration goes from minus 1 to 0. So first we'll substitute here x is equal to 0. So we have here 0, then here also we have 0, and then we have the negative sign, and then we'll take x is equal to minus 1. So we have here minus 2, and here we have minus 3 over 2, and minus 1 square, and minus 1 square is positive 1. So this is 0, and we have minus, and this is minus 2 minus 3 over 2, and this is plus 2, multiplying these two numbers by a negative sign. So we have here a plus 3 over 2. So this is 4 plus 3 over 2, that is 7 over 2. That is 3.5. Right? So the value of this integral is equal to 7 over 2 or 3.5.